Hello, today we're going to talk about proportions. What is a proportion? A proportion is an equation with a ratio on each side. It's also considered a statement where two ratios are equal. What do we use proportions for? Proportions can be used for many things, including conversions, percents, rate problems, and scaling. How do we set up proportions? Let's look at this example. 3 gallons is equal to how many quarts? We know that 1 gallon is equal to 4 quarts. What are we comparing here? We're comparing gallons to quarts. So we have 3 gallons, but we don't know how many quarts we have. And we also know that 1 gallon is equal to 4 quarts. So we set up our proportion with gallons on the tops and quarts on the bottom. Notice that when we use a variable for the unknown value. Solving proportions. In order to solve proportions, we use a process called cross multiplication. In cross multiplication, we simply take the top number and multiply it by the one that's across from it, and the top number on the other side and multiply by the one across from it. So in this case, we have 3 times 4, here 3 times 4, and x times 12, 12 times x. This gives us 12 equals 12x. To finish solving, we divide both sides by 12, so x is equal to 1. And we can check this by checking that 1/4 is the same as 3/12. Second example, 24 over 36 is equal to 2 over x. We can do the cross multiplication. 24 times x is equal to 2 times 36. 24x is equal to 72. We complete solving it by dividing by 24. 24x divided by 24 is x. 72 divided by 24 is 3. So x is 3, and we can check 24 over 36 is equal to 2/3. Our last example, we have x on the top. X times 42 is equal to 14 times 6. We can divide both sides by 42 to complete solving. 42x divided by 42 is x, and 84 divided by 42 is 2. So we get x equal to 2. 2 over 6 is equal to 14 over 42. So let's look at a couple of examples on some applications. Earlier I told you we can use proportions to solve percentage problems. So let's talk about basketball. Tyler Zeller shoots free throws with 80.8% accuracy. If he made 63 successful shots, how many did he make altogether? So we're going to look at the part over the whole. Okay, the part is that he makes 80.8%. So 80.8 goes on the top. The whole is the 100%. He made 63 successful shots, which means 63 is the part, and we don't know what the whole is. That's what we're trying to find. How many did he make altogether? That's your whole. So we cross multiply. 80.8 times x is equal to 63 times 100. We get 80.8x equals 6,300. We divide both sides by 80.8, and we get that x is equal to 77.97. Rounding up, we get that Tyler Zeller would have taken 78 free throws if he made 63 successful shots. Make sure that we always write our answer out. We want to make sure that we know the answer to the question, not just solving the problem. Another example, if we're doing a science project, we need 6 milliliters of acid for every 5 grams of product. If you want to produce 45 grams of product, how many milliliters of acid should you use? This is something you may routinely use in chemistry. So we have how much acid and how much product. Those are the two things we're comparing. If you have 6 milliliters of acid, we get 5 grams of product. So we want to know how many milliliters of acid we need. We don't know how much acid we have, but we want to make 45 grams of product. So we make x our acid and 45 our product. We cross multiply. 6 times 45 and 5 times x. This gives us 270 is equal to 5x. To finish solving, we divide both sides by 5. Dividing by 5 gives us x equal to 54. And again, make sure that we go back and answer the question. Our question was, how many milliliters of acid should you use? So our answer to the question is, you need 54 milliliters of acid to make 45 grams of product. Our last example is on scaling. You're drawing a picture of the Eiffel Tower for an architecture project. It's 320 meters tall and 74.24 meters wide at the base. If your paper is 20 inches tall and you want to use the whole piece, how wide should the base be on the paper? So here we're comparing the actual image with the image we're drawing on the paper. So in the actual Eiffel Tower, we have 320 meters. We want that to be 20 inches on our paper. So we put the actual as 320 and 20 as the image. We also know that in real life, the base is 74.24 meters wide. So that goes where the actual is. X is what we want it to be on our paper. So once we set it up, we cross multiply. 320 times X is equal to 20 times 74.24. This leaves us with 320X equals 1484.8. To finish solving, we divide both sides by 320. This gives us X equal to 4.64 inches. And again, we go back to our question. How wide should the base be on the paper? If the height is 20 inches, the base should be drawn 4.64 inches wide. The last thing I'm going to leave you with today is something to think about. Think about what you know about solving equations. Why do you think that cross multiplication works? Think about that tonight and we'll talk about it tomorrow in class. Everybody have a good night.